Right, I just want to revisit the standard normal distribution so you've got a bit more idea of why it's useful. And then next statistics lesson we will have to use it a little bit to find the mean and the standard deviation when they're unknown. So we tend to use Z for standard normal distribution, and Z is normally distributed with a mean of 0 and a standard deviation of 1. What that means is whatever your Z value is, so whatever your value of Z is, it's telling you how many standard deviations you are away from the mean. So when Z equals 1, you're 1 standard deviation from the mean. When Z is 2, you're 2 standard deviations away. Minus 2, 2 to the left, and so on. So you can do things, I think hopefully you've grasped this already, but you can do things like the probability minus 2 less than Z less than 2 to find that probability of being 2 standard deviations from the mean, which I've been drumming this into is about 95%, obviously not exactly, and so on. So what's useful about this is we can map any normal distribution onto the standard normal curve. So for instance, if X is normally distributed with a mean standard deviation, then you can map onto the standard normal curve using Z is equal to X minus the mean over the standard deviation. So this here is the distance from the mean and then this bit here is your standard deviation. So if you divide the distance from the mean by the standard deviation, that gives you the number of standard deviations you are away from the mean. You might see that easier in an example. So say X is normally distributed with a mean of 10 and a standard deviation of 5. And we've got a value X is equal to 17.5. Then its corresponding Z value is equal to 17.5 minus 10 divided by 5, which is 7.5 over 5, which gives you 1.5. So this value X in this distribution is 1.5 standard deviations to the right of the mean of 10. And then mapping onto the standard normal curve, you're just looking at how many standard deviations are you away from the mean. And you can map every value in that way. So we'll use that next lesson, but I thought this lesson you could just find a few probabilities using Z instead, so nothing too onerous at all. Just to note, I don't think you'll need it, but in case you ever see this, the probability that Z is less than a particular value on the standard normal curve has a special notation, and it's phi. Oops, sorry, it's not 5Z, it's phi of A. So that's the probability of being to the left of A on a standard normal curve. Let me write that slightly nicer. That should be like going through the middle. Gone one way and then the other. So all I want you to do today is just get a feel for that, but it's really the same as you've been doing. So just do a few, and if you're happy to, you can go on and do some consolidation work for your test. So for this one here, I'm going menu 7, probability Z is less than A, so I'm looking for an inverse normal. Area is 0.8, standard deviation is 1, mean is 0, and then A is 0.8416. So if you think about what that means, it means that in any normal distribution, actually, if you're 0.8416 standard deviations to the right of the mean, then that probability there is 0.8. This one here, you just need to think about this one a little bit. So if minus A is less than Z is less than A, and the probability sitting in here is 0.6, then your calculator only does less than probabilities on the inverse normal, but you can split this in half because of the symmetry in the graph. So sometimes you just have to use the properties of the graph a little bit. So that little bit of area there is 0.3. This area here all the way back is 0.5. So if we're trying to find A, then this is the same question. It's saying, okay, what's the probability of Z being less than A equaling 0.3 plus 0.5, which is 0.8. I didn't intentionally do this, but anyway, same question as before. So 0.8416. So we just do a few of those. Make sure you're okay with the sketching. Some questions you need it more than others. And that'd be it for today.